integrated, it's seamless, and it provides a lot of good tools for the designer in the AEC industry. So Laura has already introduced my qualifications, so you're welcome to email us and ask about classes that we offer. I'm going to go ahead and get started with this presentation. So this webinar covers the recent conceptual massing advancements in building information modeling. So sketch effortlessly in 3D perspective views utilizing Google Earth data in Autodesk Formit, Vasari, and Revit. And also utilize Autodesk Civil 3D from your civil engineer to download topo data into your Revit. Compare and contrast federated 2D line-based design tools with 3D information-rich models. And no matter how complex the geometry is, you will be able to quickly create and evaluate model-based floor areas, mass volumes, and surface areas. The learning objectives for this webinar are discover exciting new tools such as Autodesk Formit, Falcon, and Vasari. Some of you may know Revit. From the poll that we just introduced, it looks like we have the majority of you have about 2 to 3 years of Revit experience, but we have quite a few who are who have little experience in Revit. So this will be a webinar that covers everything for the beginner user and for the advanced user as well. The second objective is to utilize Autodesk Civil 3D to download Google Earth topo data and import into Revit. Third objective is to compare federated 2D line-based design versus 3D information-rich models. The fourth is to explore parametric workflow in regards to design visualization and area analysis. Also, we will learn how to create and evaluate proposals in regarding to BOMA space types. So as you know, conceptual design and master planning in the architecture industry has been around for a very long time. And physical models as well as site plans have been, or master plans have been created using all types of different tools, all the way from hand sketching to colored plans to 3D models that are done by hand. The only problem with this proposition is that they're too expensive, they're time-consuming, and difficult to change. The lower part of this slide shows the city of Hong Kong, Bay Area, modeled in 3D model. But then, of course, can you imagine if you want to make a change to one of these buildings? How long will that take, and how expensive it will be? Most of us have background in 2D CAD platforms, whether it's AutoCAD or other CAD software. The issue with these CAD software is that they are line-based. You know, lines, arcs, and circles represent buildings or site master plans. Making change to these drawings is time-consuming, of course, and it's also fragmented. You have the plans in one area, you have the elevations, another drawing, you have the sections and schedules in a different drawing, and then they're not talking to each other. So what we're going to show you today is a little bit different workflow. Here's the start of a workflow for the AEC industry by using Autodesk Formit. Of course, Formit is mainly runs on the iPad platform, but there is also a recent app for the desktop. So you'll be able to download that from your subscription website. And here's my colleague, Michael Zeveld, who is starting his Formit model on his iPad and basically just going to Google Earth, grabbing an image from Google Maps or Google Earth, and then for a specific project in Cobb County, Georgia, and locating that site, turning off the maps, and then turning on the satellite images, and you'll see this is a retail center with buildings and parking. So he's going to bring that into his Formit model, and start by doing some simple masses in Formit. Of course, he's using his just fingers and touch screen for that. Setting the dates and the time of the year for the actual model helps you with creating the appropriate location and latitude and longitude for that project. It is very intuitive. It follows essentially the working with primitive masses, cubes, spheres, cylinders, cones, etc. And simply just by pushing and pulling on these masses, on these surfaces and edges, you'll be able to control the size of these images and be able to scale them to fit that aerial image. It takes, of course, a little bit of practice, and this is an early example of how to use Formit. Formit, of course, is changing every day, and with the most recent version of Formit, you'll see a little bit more functionality, a little bit more user-friendly interface, and you'll have more control over your masses. By pushing and pulling on these buildings, you'll be able to tweak them just like a clay model, if you will. And what's beautiful about Formit is that you'll be able to take that model, upload that to Autodesk 360, and then convert that into a Revit file, an RVT file. So a lot of those software that we have mentioned are compatible with each other, and you can push data between them. So this was the Formit demo. Let's go into the Civil 3D demo. So at the same time that you are looking at this project from a conceptual mass environment, maybe sitting down with your client and just playing with forms, you could have your civil engineer either do a real survey for that property or simply just grab an image from Google Earth. And that image comes, believe it or not, comes with a topo information. Now this topo information may not be accurate, but it is probably okay for conceptual design. We don't want to sometimes spend the money to an expense to send someone down to the job site to be able to do that survey. So this would be appropriate for conceptual studies, and it also pulls the elevation of these contour lines into Civil 3D. Now the beauty of this is that all of this eventually is going to end in Vasari and Revit. So we talked about Formit, which is either a desktop app or an iPad app. This is Vasari. Now it's in beta 3, and it is the conceptual design tool of choice for Revit users. If you haven't worked with Vasari before, I encourage you to go to your, just Google Vasari, Autodesk Vasari, and download a free copy of Vasari. It is 100% compatible with Revit format, so it uses the same RVT file format as Revit, and allows you to work in the same ease with all the other apps and cloud storage and sharing, just like Revit. It has some added functionality, such as working directly in perspective views. You see here, I took that mass model from Formit in RVT format, download that from Autodesk 360, and brought it into Vasari in perspective mode. And so a lot of you who have been using maybe SketchUp in the past or some other 3D modeling software notice that there is a lot of similarities between this and the SketchUp user interface. Very intuitive and user-friendly, but what's important about this is that everything you do here is not lost. It is preserved for you and becomes a valid Revit geometry. So you'll be able to take that from conceptual design through construction documents without having to do a lot of rework. You see a lot of things that can be done in Formit can also be done inside of Vasari and Revit, just a little bit different way. And maybe here it's a little bit more accurate because now I'm able to assign specific heights for the building mass and be able to very quickly model this footprint of this project site. Here I'm making sure that I have the correct orientation of the building, orienting the project north and the true north, and start to assemble this this model. And you know, you may be some missing parts. You can add them in. Nothing fancy or difficult. Very intuitive, easy to use for the average user. May take a couple of clicks to get used to the interface and get your design intent going. Of course, I'm not going to show every mass in this project. I'm going to simply just skip to the next part of this and show you the end result. Here we have several masses that are maybe symmetrical to each other on the other side of the development. So I'm simply going to just mirror those to the other side. And now we have a valid footprint on top of this topo, and this allows us to very quickly study these masses in terms of their volume, in terms of their area, in terms of the perimeter information, and in terms of the surface area. So I'll be able to not only create flat box shapes, but also any kind of complex geometry using mass floors and including organic geometry, and be able to slice the models using levels. And simply Revit will take care of the computation for you as far as the floor areas, perimeter, and volume information. This is interactive. For those of you who are Revit users, know that this is change it once and changes everywhere, and you'll be able to go through each of those building masses and adjust exactly how many floors does it have, and your schedule will respond automatically. This information, of course, is very valuable for the building owner, and because they're able to interact with the designer in real time. So here we're going to this a little bit more complex geometry using simple cylinders, and then by pushing and pulling on these control points, we'll be able to create some interesting shapes. Some of us may call them funky shapes, but they are very maybe this will represent the vestibule of the building, and you'll be able to interact with these masses in 3D, in perspective view, and those will turn into simply walls, floors, roofs for the building. Now, in the early conceptual design, you may want to study the impact of the environment and the location on this property. So you may, if you are in Vasari, you can go ahead and launch the solar radiation analysis and be able to, with very few clicks, be able to get a quick feedback on what faces of these masses are receiving the most sun. So here you have, with this legend on the left, you'll see that the yellow is the areas of the building that are receiving the most sun, and blue is the least sun. So if you are concerned about heat gain, heat loss, you may not want to put a lot of glazing or windows in the yellow areas of the building. That is very valuable information for the architect early in the design process. So you don't want to just go ahead and get on creating lots of curtain systems where the buildings receive the most sun, because that would not be very efficient from a sustainable design standpoint. Here we're going to the windrows diagram, studying the wind direction in the metro Atlanta area, and being able to also study the flow of the wind across the building. Here we're bringing in the topo information from AutoCAD Civil 3D, which is an AutoCAD based, but it's 100% compatible with Revit site tools. You'll be able to generate the topo information using the site point by point XYZ coordinates, and this topo is going to act as your site model. It may end up being a different elevation than your building, because your building is sitting at 0 elevation, while the topo itself is sitting at 1,000 feet, which is where the East Cobb area is located, above sea level. So here we have, we're starting to get some sections elevations, schematic sections elevations for the development, and it's starting to get to relate where the building is in relationship to where the topo is. Now we see that, you know, we have some grading to do for the site. There's some cut and fill involved, and Revit is going to be able to track that for you as you work with the grading feature of Revit. So we're using the phasing feature of Revit to track the grading, cut and fill. And again, this is very schematic, but it is accurate in a lot of ways. We simply can, from an architectural standpoint, this is probably more information than we need. It may not be civil quality information, but it is fairly useful for the early conceptual design. We're laying out here the parking layout that probably came from a different software, such as AutoCAD, on top of the retail development. And start to understand the relationship of the spaces between, you know, the solid and the voids, and go ahead and use those masses to generate building elements such as walls, floors, and roofs. So all the work that we did in Formit and Vasari and Civil 3D is all coming together nicely here, seamlessly, without having to do a lot of rework. That's what I like about using the Revit platform and its compatible software, because everything you do is useful. Everything you do is going to be, has value downstream, and you'll be able to use that for your future work in DDs and CDs. So moving along, another way to analyze this development is using Autodesk Falcon. Falcon is a desktop-based wind analysis tool that runs on your desktop, and while the Vasari that you saw earlier is a cloud-based. So again, different ways you can analyze the building and get feedback information on its building, on the performance, and you'll be able to make some intelligent design decisions that will meet your design intent and the project goals. This is very schematic, but it's useful to make sure that your building meets certain performance criteria. Okay, this is where it's going to get a little bit more interesting. So now that we have fixed the footprint of the building, we know exactly where the buildings are, we know that the parking fits, we have the proper number of parking stalls. We're we're going from schematic design into DDs. And this is where we look at the building a little bit closer, make sure that we have the proper areas that are programmed for the tenants of this building. This is a retail development, so every inch counts for the landlord because they charge rent for every square foot of the building. Again, this is not rocket science. It's fairly straightforward, just point and click, turning the AutoCAD vector data into Revit 3D massing. Same thing, you could do that by scheduling the massing themselves, the masses themselves, and turn those into valid areas, volumes, and perimeter information. Changing the level to level height is not a problem because Revit is going to take care of that behind the scenes for you. As you can see here, we're quantifying the areas of the building, making sure that we are within the program requirements and meeting clients' goals. This is the time to adjust and make changes to the design if need be before you actually turn this into an actual building. Again, by using massing by face, you're able to use building components to attach them to our masses. We can get at this point, since we know the footprint is working, we can just go to the next level and make this a little bit more detailed by, looking at roofs, looking at parapets, looking at entrances, curtain systems, and looking eventually at tenant areas and demising walls. Here's the parapet above the roof being created. Here's our entrance for the retail shopping center. Turn this into a curtain system. Remove those mullions at the front. Now we have a double door ready for further design analysis. Okay, so how does that work in terms of BOMA lease plans and gross versus net areas? Now in CAD systems, of course, it would be very difficult to be able to make a change in the plan view, and that changes in the schedule. While in Revit, of course, you'll be able to track the areas of the tenants, even if you moved a demising wall, everything is updating in real time. Of course, with the BOMA standards, Revit is able to track whether this is a common area, an office area, a major vertical penetration, or otherwise. Here's a demising wall being relocated 5 feet, and you can see that the tenant area is being updated, while the AutoCAD background just remains the same. Now, using color fill legends in Revit, of course, is maybe common to some of you guys who are out there who are advanced users. So you should be able to handle this no problem. Changing the legend color coding, color scheme allows you to tap into this information-rich model, get information you need in terms of tenant names or areas or any other information that you're looking for. So this brings us to the we are nearing the end of this presentation. I just want to mention that we've talked about a lot of software today, and I want to make sure that you guys understand that these software come in buckets in terms of what they do. So this is kind of a short list of best-in-class BIM tools that we mentioned several of those today. We mentioned some of the authoring tools such as Formit and Revit and Civil 3D. We talked a little bit about analysis, that is the Revit energy analysis or the Vasari wind analysis or Falcon. But there's other tools out there that will help you in your conceptual design, including InfraWorks for master planning and large-scale planning, Navisworks, and other web-based analysis and simulation tools that I encourage you to check out and make a note of. So before I turn it over to Laura, I want to, and then we'll take our questions. I want to go back and emphasize and stress some of the business benefits of parametric BIM workflow. So if you're still maybe working in a 2D CAD environment, or maybe using a hybrid approach, but not taking advantage of the information workflow that we have showed today, you may want to look at these a little bit more carefully. So basically, we're not compromising anything when we use this workflow because there's no rework. You're making more informed design decisions. So from a business standpoint, it is very profitable to be able to base your decisions based on proper information. You can better predict project outcomes through visualization, simulate building systems and structures, document with systems coordination in mind, deliver documentation models and renderings throughout the project lifecycle, and develop competitive advantage. And the last is to expand services offerings. So if you, right now, as an architect or as an engineer, you do not do these things, maybe because you just don't have time for them or you didn't know about them, this is the time to adopt and embrace these technologies, or whether it's desktop-based or cloud-based or mobile-based technologies, to make it part of your daily workflow and put it to use for you. So with that, I'm going to turn this over to Laura, and who is going to explain to you what are some of the next steps and take your questions. Laura?
Thank you, Rabbi. And I'm really pleased that today's presentation I hope that will be very valuable for your everyday use. And listed on this slide right now, you can see the various Revit classes that we're offering. And InfraWorks and 360 Sustainable Design will be coming up on the LiveLab Learning website very soon. You can either click on the link below, or you can click on the LiveLab Learning logo to the left side, and they'll also take you to the link of the web page where you can register for classes. Again, thank you so much for taking the time to review our presentation today, and thank you, Rabbi, for giving an excellent presentation. And now I will open up the floor for any questions. You can feel free to write the questions on there in the questions pane, or you can start talking right now. Okay, if no one has any questions as of now, let's close this webinar today, and thank you so much, and we appreciate your participation today, and we look forward to seeing you next time. Have a nice day.